3, 2, 1. Howdy, howdy, this is Mr. Potter. In today's video, we're going to talk about two other aspects of Python programming using our turtles. One is going to be to fill the shapes that we're drawing, and the other one is to use variables, and we're going to talk a little bit about both in today's lesson. To start off, though, we're going to go to sculpt.org because that's where our Python programming is. So here's our default program, and we're going to go ahead and get rid of everything except for the library and the constructor. And I actually want to start with t.color. Because we are talking about filling stuff in, we are talking about shading, I want to remark about this method. What we had talked about before is that I could put in any color I wanted to. And we talked about how we could actually put certain color names in text, but if I wanted a user-defined color, we could put that hash and then a hex code for it. Remember the 3 hexadecimal bytes. So I'd have FF0000. And that would be an example of full intensity red, because FF is full intensity. 00 is no, so I'd have no green and no blue, so this would be a red turtle. And if I ran this, you would see that my turtle comes out to be red. No shock there, but if I were to add a second parameter in here, in other words, put another hex value, maybe like 008080. So this is a hex color with no red, with 80 is half intensity, so I've got half intensity green and half intensity blue. So this is going to be that dark teal color, that aqua color. And if I run this, you'll notice that this triangle, if I run it, actually changes color. It's kind of hard to see, so I'm actually going to make my turtle bigger by using t.shape. So if I make it the turtle shape, then you'll be able to see this a little bit better. You see that I've got a red outline for the turtle, but the interior of the turtle is that teal color. So I've got this ability to kind of do double duty with the color. I can have one color for the outside and I can have another color for the interior. And so this allows me to have some fun when I'm doing shading, because clearly I can make a shape. Let me make a triangle real quick. I know a triangle has 3 sides, so I'm going to create a loop here. So for index in range 3, and remember that everything that I want to repeat has to be inside this white space. So everything has to be lined up with this I in index. And I'm going to tell my turtle to move forward 50 pixels, and then I'm going to tell my turtle to move left 120 degrees. Actually, no, just 60 degrees. Actually, no, I do need 120 degrees. And so what this is going to do is this is going to repeat this. If I just run this, that's going to give me a red triangle. And it only gives me a red triangle because I haven't told it to fill. So I want to talk about how we fill a shape like this. So what has to happen is at the beginning, I need to tell the computer this is the start of a fill region. And the way I do that is with t.begin_fill. And so this is telling me, hey, computer, I'm getting ready to start filling stuff. This is my starting point, which means everything between here and when I tell it to stop filling is going to be filled in with my teal color, my second color choosing that I declared up here with my color. So after this loop, if I go back and move over here so it's not aligned with the I, this is something that won't get repeated. If I do t.endFill, so I've got t.beginFill telling the computer this is the start of a fill region. And then down here, oops, let's move that back. I'm going to have to tell the computer this is the end of a fill region. So with the t.beginFill and the t.endFill, this is what's new in today's video. If I run this, it's going to trace out the triangle, but then immediately after I've done this last part of the loop, it fills the triangle in with our default color. Or not our default color, but with our second indicated color, this teal that I had, this second parameter of color. And so this allows us to do some interesting things, because now I can say, okay, I want the outside to be one color, but I want the inside to be a different color. I can have something where the outside is black. Remember, black would be no intensity red, no intensity blue, no intensity green. And I could have the inside be yellow. Remember, yellow is full red, full green, and no blue. And if I run that, I'm going to have a black shaded triangle, but inside it's going to be, I'm going to have a black drawn triangle, but the inside will be shaded yellow. So that's the first thing that I want to talk about. The idea that if I want to fill in the shape that I just drew, what I need to do is I need to use a second parameter for color. So the second parameter is the fill color. And the first parameter is the drawing color. We're familiar with that already. But then I also want to use begin fill and end fill to tell the computer start filling here and stop filling here. So that's the first thing that I want to talk about. The second thing I want to talk about is this notion of variables, because there are some times when we want things to change as we go through the program. Now notice I currently have this program set up to draw a triangle, and I know it's a triangle because I'm repeating the drawing of lines 3 times. And this angle is set up so that I'm drawing 60-degree angles because my exterior angle is 120 degrees. That's how much my turtle is turning. If I wanted to draw a square, what I'd have to do is I'd have to change this number to 4, and I'd have to change this number inside the parentheses for turning to 90 degrees. And if I did that, it would draw a square and shade it, of course, because we've got the begin fill and the end fill. If I wanted to do a hexagon, I'd need something with 6 sides, and I need to make sure this angle worked with a hexagon. I know hexagons have a 120-degree interior angle, so the exterior angle would have to be 60 degrees. And so that would get me my hexagon here. What I can do, though, is I can have a variable that takes the place of this. So rather than having to change 2 things, I only change it in 1 spot. So what I'm going to do is talk about a variable. So a variable is an expression that holds a value to be used later. So what I'm going to do is I want to say, hey, I want the num sides to be equal to, let's say, 6. So that means whenever I see a 6 here, I don't want 6, I really want num sides. That way, all I have to do is change this, and it changes not only the number of times this loop gets run, but also this angle. Keep in mind that when we were a triangle with 3 sides, I had 120 degrees for my exterior angle. When I had a square with 4 sides, I had 90 degrees for my exterior angle. And now that I'm dealing with hexagons with 6 sides, I end up with 60 degrees. And so I figure out, oh, the way this is being calculated is I'm taking 360 degrees and I'm dividing it by whatever the number of sides is. So I can have the computer do that heavy math for me. Because if I want to draw a pentagon, I don't want to have to think of what 360 divided by 5 is. It's 72, by the way. So, but if I just make that a 5, this is going to run it 5 times, and it's going to automatically calculate what that angle should be. So there's 5 sides, and notice that all these angles look good. And, you know, heaven forbid if I tried a 7, 360 divided by 7, I don't think it even goes in evenly. But if I run that, then I end up with a heptagon, and my heptagon looks pretty good. I can even make this a dodecagon. I can make this a 12-sided figure. And there are my 12 sides being drawn. And one of the other things that you notice is that the more that I go through this, the closer this thing looks like a circle. Also, this thing is getting bigger, and I'm running into danger of this going off the screen. As a matter of fact, if I were to make this 15 sides, then I do end up with my turtle actually going off the top of the screen. Now, of course, I could fix that with the set position or the set Y that we talked about in the previous lesson just by having my turtle start a little bit lower, but I think this illustrates the idea. What I could do to compensate is I could say, okay, let's actually make this, say, 200 divided by num sides. And that'll kind of make sure that this shape always has about the same shape. So if I jump back down to 3, here's my triangle with 200 divided by 3, which is about 67. If I make this a square, then I have with the square, that's going to be 200 divided by 4, which is 50. And if I make this a decagon, a 10-sided polygon, notice that all of these shapes kind of have the same height. They're all kind of contained in the same region. Probably be safe enough to actually make that up to a 400 just to make it a little bit more visible. But I want to do one other thing. I'm noticing that the bigger this number gets, the closer what I'm looking at looks like to a circle. I mean, keep in mind, this is a 20-sided polygon, but this looks very close to a circle. And if I were to make this, say, 360 degrees or 360 sides, then of course my turtle is slow, but I know how to fix that. I can change the turtle's speed to make the turtle go faster. And what I'm getting is a very, very smooth curve. Now keep in mind, this isn't a true circle. This is a 360-sided polygon. But all it's doing is it's turning 1 degree to the left every time. And it's basically taking 400 divided by 360, so it's only moving about 1 pixel each time. And of course, we talked about how we could change the turtle's speed. So let's do t.speed to 10, because remember 10 is our fastest speed. And if I do that, even though this is the faster speed, my turtle's still moving very slowly. But I do have this idea of a parameter, okay? This is my variable. This variable affects the number of sides, the angle between sides, and the height of the polygon. And so all of these things are determined by this numSides parameter. Now, of course, I could really confuse the computer and do something like, what if I had a 2-sided polygon? Well, if I had a 2-sided polygon, what would happen? It would draw 200 pixels forward, in other words, to the right, make a left turn that was 180 degrees, which means it would essentially trace back on itself. And then it would try and fill what is, in essence, a line segment. And so the issue that I run into here is, of course, what does a 2-sided polygon look like? And I would imagine it looks kind of like an infinitely thin coin. So 2 things that we talked about here in this video. One thing is we talked about how to fill a shape. So let's go ahead and make this an actual shape. Let's make it an 11-sided polygon. So I'm going to have 11 sides here, and it uses begin fill to start the fill region, which we've got right here, and it uses end fill to stop filling. And everything between those commands is going to be a shape that's filled. And we also talked about the idea of a variable. So I have this numSides, which keeps track of several things. Number 1, it keeps track of how many times a line segment is being drawn, how many sides my polygon has. But it also keeps track of how far do we go for each path. That way my polygon always stays relatively the same size. And it keeps track of how much of an angle we turn. So we're only turning enough of an angle to make a true polygon. So once again, this is Mr. Potter. Thank you for watching. Have a great day.